Hey, welcome to part 3 of the Building AI Agents tutorial series. In part 1, we covered basics like what AI agents are, how to use tools and memory, and if you don't know what I'm talking about, go watch part 1 and 2, then come right back here. In this video, we're going to focus on prompt engineering specifically for single task AI agents. So an AI agent is software that can autonomously complete tasks on your behalf. Now, some people say they're all hype and not production ready, while others are seeing success by using them because they're deploying agentic use cases where they have well-defined tasks with well-defined scope. There are countless well-defined tasks out there, from booking an appointment to working inside of a CRM on a specific task. Plus, it's fairly easy to add some sort of intent routing before your agentic steps in your workflows. So that's why we're going to focus on single task, so you can learn the best practices around getting a task done, which you then can apply to having a multitask agent. But I highly advise, especially if you're getting started out, focus on having your AI agent do one thing well and then expand from there with various different strategies that we can get into in follow-up videos. So do drop a comment if you'd like me to get into that after watching this. The biggest lever you have in driving the success outcomes of an agentic solution that you're working on is in prompt engineering. There's other things like tool calling and even fine-tuning and distilling of LLM models that you can do, but prompt engineering is going to have the highest effort to impact ratio. So how I like to think of prompt engineering is it's essentially an instruction manual that you're giving to an intern, and you work at a company that has async work culture. You're the manager, and your job is to onboard this person, have them complete tasks and create business value by only handing them off this manual, and you're not allowed to talk to them. So you might be able to update that manual over time, but the success of your employee that's been assigned to you is wholly predicated on you handing them off a manual that is self-evident, clear, and has the relevant context, teaches them how to use tools that they might need to get tasks done, teaches them the order of those tasks, and perhaps gives them relevant examples of how that task is done. So prompt engineering is the handbook you give that intern. That's going to be true today and over the next few years, even as the AI landscape evolves. That intern may become a junior, that intern may even become a senior with some of the model evolution that we're seeing right now. Either way, you're still, for the foreseeable future, going to need to be able to instruct them precisely on how to do the things that you want to drive the outcomes that you need for yourself or your business. I'll also call out that this is going to be specific guidance for AI agent prompt engineering. When I was doing my research, I actually saw a lot of guidance that wasn't particularly relevant in AI agents. Those tutorials were assuming that you're working with just raw LLMs. So everything you're going to learn here is specifically for how to build AI agents. And throughout this series, we're using N8N, a workflow automation tool, with some pretty kick-ass AI agent building features in them. If you want to follow along on our cloud product, make sure to use my coupon code MAX50 to get 50% off for 12 months. You can also self-host. All right, without further ado, let's jump in. I like to think of prompting occurring on 3 distinct different layers within an agentic system. The first layer is the system layer, and this is where you're specifying the role of the AI agent, its rules, how to complete the task, and certain types of context. Then in layer 2, we'll have a look at the input layer. Agentic systems expect an input. This is the request, the task, and then they output based on that task. And then thirdly, there's the action layer. So there's various tools and functions that AI agents can leverage, and those tools need descriptions and definitions so the AI agent can use those successfully. So that all happens in layer 3, the action layer. So let's jump into N8N and have a look at layer 1, the system layer. So I'm in the workflow canvas in N8N, and I've got a basic AI agent in here. So I've got a chat trigger connected to my AI agent, and I'm using a Google Gemini model here. But again, you could use a different chat model. In this system layer, we're going to go over a few different aspects to build out that system layer, or that system prompt. And the first one is role prompting. So role prompting is explaining to the AI agent what their role is, who they are. Not necessarily what they're doing, although there's elements of that, but it's the who they are. So I like to think of this as the first couple sentences in a job description. And the reason roles can be helpful is, as you see here, we're going to add instructions, we're going to add rules, we're going to give it quite some guidance on how to do its things. But by defining a role, we give it this, 50,000 foot view of context when there's ambiguous situations. So that's why role prompting is a good first thing to do, because it sets the frame of who the AI agent is and what they'll be doing. Let's open up my AI agent and define that role prompt. Now, as I teach all these different skills, in this video, we're going to do it by building a booking assistant for a beauty salon. Now, I just picked a beauty salon, so there's something specific and concrete, and you can see how that informs the words that I basically pick that go into my prompts, but this can be applied to any use case. Okay, let's open up the AI agent, and the role prompt and everything you're going to see in the system layer is defined in the system message. So to add one, we click on options here and we add a system message. There is a default system message added. Here we can see it saying, "You are a helpful assistant." That is role prompting. It's a really basic, really simple role prompt, but that's role prompting. Let's clear that, however, and write our own. Before I do that, to have a bit more working room, let's just expand our parameter pane here. And actually, some users don't know about that. So yeah, you can expand that and move it about, which is helpful. I'm going to paste it in, but then we'll walk through it. You are a scheduling assistant working for a beauty salon. Your role is to help customers schedule an appointment in the beauty salon's calendar. Okay, what am I doing? At a very high level, my roles typically have a format of you are a ... Your role is ... The you are a does not define their task. It doesn't mention it. It defines who they are. You're a scheduling assistant working for a beauty salon. I see a lot of folks, perhaps at this stage, they would say, you're a Google Calendar assistant. That actually doesn't provide a lot of context to the AI agent on what they're supposed to do, how they're supposed to interact. Perhaps a Google Calendar assistant could be a virtual assistant whose job is to make sure that things are booked really close to each other so they're super efficient. Versus for customer service, that might not be as important to you. Making the customer happy might be. So role provides that very high level context to guide it. You're a scheduling assistant. This would make sense if it was a person as well. And your role is to help customers schedule an appointment in the beauty salon's calendar. So a few points to point out. I mentioned beauty salon here, and I use the exact same words here. So AI models are able to understand semantic similarity between things. So if I just wrote salon, that would still work. But it's a better practice to use the exact same word because it's going to be a stronger match. And then in this role, I am lightly giving context to what it will be doing in terms of a task, but I'm not specifically defining it, right? I'm not saying Google Calendar here. If you did, it probably wouldn't be an issue, but that's one thing, is trying to separate concerns. So we'll define in the tool that we'll use, the Google Calendar tools, we'll define that it's Google Calendar. At this stage, it's better to separate that out, because what if we switch calendars in future? You might have an issue because you're saying Google in your role prompt. So we keep it high level here. This is a sufficient role prompt for the scope of our agent. And since we're going to be adding other sections, we're going to actually use a markdown format here. So this is a H1 title, and just write role here. If you're writing short system messages, you don't really need this. It's firstly helpful for yourself. And then when your system messages get larger, it can be helpful for the AI agent, although I expect that its efficacy will reduce over time as AI models get smarter. With the role prompting done, let's define the list of instructions the AI agent should follow when completing the task. Now, this is a balancing act, because if we're too prescriptive in the steps and end up defining a workflow, we lose the autonomous benefits of an AI agent. So this is giving it the high level steps, kind of like if you were completing a task, you might think of it at a very high level before you go do that task, which might help you improve how you do that task. Same thing here. Let's open up the AI agent. And let's add a instruction section. Now, what's going to happen next is we're going to have a list of instructions, like number 1, number 2, it's going to be a numbered list. Since this is an instruction manual to an AI agent in sort of a first-person voice, what we can do to improve this list before we add those numbered steps is preface it. Follow the following steps to book an appointment for the user, and then the list of steps. If this was a copywriting class, follow the following steps, doesn't sound very good. But the AI agent isn't going to be judging you on your copywriting in that regard. What I encourage you to do before you write out AI steps is have a quick think, like as a human, what you would do. So we're a booking assistant for a salon, right? So someone calls, what happens? First thing is the assistant says, well, which day would you like an appointment? And then it takes the user's day and it checks for that day. There's going to be availabilities or there's not. So either it's going to have to ask the user, hey, that day's not available. Is there another day? And then it'll find some availabilities for a day. And then it'll ask the user, hey, here's availabilities. Which would you like? The user will say, and then it will attempt to book it. Before that, it needs to ensure it has all the information it needs from the user, their name, their email, right, to book that. And then it books that is either successful or not. And then it replies to the user. So quite a few cases that could happen. Quite a few situations, I mean, the user might say, hey, what about Sunday? They're not open on Sunday, right? There's all these details here. But let's break this down into the key parts and then allow our AI agent to make decisions within those steps. So for step 1, we want to ask the user for their preferred appointment day. First person voice, nice and clear. And again, here we're saying appointment because here we said appointment and here we're saying appointment, using the same term throughout these for consistency. So next, now that we have the user's preferred day, we need to go check the calendar and see if there's any availability for that day. So use the check calendar availability tool to identify free time slots for the user specified day. This tool doesn't exist yet, but when we do, we're going to name it exactly this. And every time we refer to that tool in role prompting, we're always going to use exactly that name. That is a best practice. Now, one thing you're going to notice here, I'm saying the user. Why? Here you'll notice I said customer. This is because in the role, it is helping customers, and how one might interact with customers could be very different to how you interact with a vendor, for example. Now, you might be polite in both cases, but again, there's a lot of nuance in how you might interact in that social interpersonal interaction. Thing is, when it comes to instructions, here, the instructions are interacting with things the user will write, and that is the user message. That's the entity through which the user on the input layer is delivering this. That's what the LLM, the AI model, understands it as. There's user messages and the system messages under the hood to the LLM model. So by saying the user, that's going to be a much stronger connotation with like the other input I'm receiving from an actor, from an entity that I know as the user. So that's why you say the user here, when it's like specific instructions that are interacting with the inputs from the user. One thing to note, when we actually use that tool, what we're actually going to have to do is for a day, define midnight of that day to 11:59 of that day, pull all the actual events, and then find the space in between, and that's what the availability is. But we're not defining that here. That is something we'll define at the tool level because that's how Gmail is going to work. But if we swap it in future, we define it here and there, it's all messy. So we're separating those concerns. So here, the step is to identify free time slot. The tool that helps you do that will define how to do that specifically. Next, we need to show the user these slots and capture their preference. So show the user available time slots for the preferred day and get from user the time slot they would like to book an appointment for. If there are no available slots for the day, start from step 1 again and ask the user for a new day preference. A few things to point out. Reference steps. You have numbered steps, you can reference them. That's why I use numbered steps, not bullet points. Next, the English here is not so good, right? Like my English teacher would be very upset that I'm ending on a 4 here, but it is specific and it's like verbose to where it would be bad if I was writing this as an article, but it's clear. It just might not be very elegant. That's okay. So next, we've gotten a preference from the user for a time slot that is available. And now we need to ask the user for the information you require to book the calendar appointment. In order to book the appointment, you need the user's full name and email. So interesting pattern I've chosen here is I'm asking it to get information from the user, and then afterwards, I'm giving it some context on what it needs. Now, here, I didn't say it only needs that. By saying ask the user for the information you require, you give some agency to your AI agent. What I mean by that is, if the tool to book the calendar appointment requires a phone number or in future has optional things and whatnot, that is going to look like a form for the AI agent to fill out. Imagine this was a real person and you're like, hey, look, this is the app that you use to book in Google Calendar. They're going to see a form of stuff to fill out. That human would infer, okay, I need to capture this information to book the appointment because I can't click the button until I fill it out. That's the same thing the AI agent is going to be thinking when it looks at your tool. So by saying, ask the user for the information you require to book the calendar appointment, you're giving it some agency, but then also some guardrails because you know it's going to need name and email. Then in the tool itself, you will be defining all the other things it might need as well. So it's a bit of a hybrid here. Removing this could also be acceptable if you want to completely separate concerns and have that only defined in the tool. All right, next step, use the create calendar appointment tool. Again, we haven't created that yet, to book the appointment for the user using details captured from step 5. Okay, so the agent's going to try and use that tool. That's going to work or not work, right? Tools can fail. Every system can fail. So once the appointment is booked, notify the user with relevant details for their appointment. Notify user if it was not possible to create the appointment. I'm defining what it should do here. I'm not going into too much detail. The reason is notify the user with relevant details. I could explain a lot on what that is, but because we're going to later show few-shot prompting, which is providing examples, showing it how you would like to show the information for a successful booking is going to be a lot easier to show via an example. So that's what I'm going to do there. We've got instructions booked. What's next? Now that we've added role prompting and some instructions, the next thing is to define rules. Now, rules is basically a list of shit that went wrong while you were building or when you were in prod and you're kind of reverse engineering how to fix that case. That's usually what my rules list looks like. I might have one or two preemptive ones that are really important for the use case going in, but this is a really quick section. So I'll open up my AI agent. Here in the system message, we've got the role, we've got the instructions. Let's add another section called rules. So in here for my use case, I've got two preemptive rules, but again, from testing, if you need to add stuff, this is where I would add it. Always use UTC+1 time zone when using tools or their outputs. So I wanted to use UTC+1 because my beauty salon is in Berlin, and it would be kind of weird if it's like you call somewhere or you're texting somewhere local, like in your town, and it's like dealing with time zone stuff. So just assume UTC+1. Now, that's a rule. It could also be a context. Like later along, we might say, hey, the beauty salon is in Berlin, but it's a rule that it should always use UTC+1. So separate from the context, right? Even though you might want to reiterate in that context that they operate in UTC+1. Next, don't make things up. Ask the user a clarifying question if you need additional information to complete your task. So while I've placed this in the rules section, this is an example of a few things actually. So don't make things up is you telling it don't hallucinate. That's a very simple strategy for having it not hallucinate, not making things up. There are more complicated ones. But so we saw that. And we say to ask the user clarifying questions if you need additional information to complete your task. It's usually a good one. You give the AI agent an exit hatch or a way to kind of like get more context from the human, which is arguably maybe the best tool it has for helping with its task, because here we're being very prescriptive on what it should do. So we give it this. Now, again, only two rules here. As we build this, we might add one or two here if we were testing it or once it's live. For example, a rule might be always talk in English, because even though the AI agent can talk 12 different languages, actually that causes problems for our ops because then people think they can talk with the people in Ukrainian or something, right? So that could mess that up. So this is where we would add those. All right, so that's rules. Now, let's look at few shot prompting. Before we get into few shot prompting, let's talk about what a shot is. So this is different from shots fired, right? This is shots in the context of an LLM model. And think of it as basically just an example. So if someone said that my AI agent has a one-shot prompt, that means they gave it one example. Perhaps it's an example of the expected output or an intermediary step, and they expect that the AI agent can complete the task based on that one example. If they provide multiple examples, this can be few shot prompting, multi-shot prompting, or n-shot prompting if you got a bit of a maths background and you like to sound fancy. Now, as a human, if you're given a couple examples of things, you're probably going to have an easier time doing a task. Same thing for an LLM. Shots can be added at different layers of our prompt engineering. System message is a common place. The user message can be a common one, but not for our use case where we have a chat interaction. That might be the case more when you're having something programmatic where, again, you're using that user message and creating that user message based on static and dynamic data and then sending it in. And in NN, AI agents have this concept of structured output. So if I check this to true, I get the output parser branch here, and I can add a structured output parser. This allows me to define the format that I would like the AI agent to output its final step. Now, this is not as helpful when you're using a chat trigger use case, because here we're expecting a text that comes out that then gets served back to the user chats with it, sends back, and the loop continues. But this could be useful for a programmatic use case where we need this to be a rather specific JSON object because we're programmatically consuming it down the line. So if I provided a JSON example in here, this would be a shot. Now you can provide a JSON example or you can use a JSON schema. If you're not familiar with JSON schemas, use ChatGPT to help you. Provide an example of the JSON you want. Say, hey, turn this in the JSON schema. Because in JSON schema, you can set the type if it's required and whatnot. There's quite some flexibility there. Most of the time, I am providing an example. But this is only for the structured output of your AI agent step, what comes out at the end. So for our use case, that's not as relevant. What I want to provide an example of, or a few shots of, is how the AI agent should communicate to the user via chat when the booking is successful. I want a nice, consistent message that gives the user confidence that their booking has been booked. To do that, let's open up our AI agent and go into my system message. And then underneath rules, we're going to add another section and call this examples. Now, since I mentioned that there could be a few different types of example, like we might provide an example of what we want the success booking to look like. We might also say, hey, look, here's a 3 example threads. This is how we want your voice and tone to sound like. So again, here underneath examples, we're going to employ these prefaces before we add the examples. So for the first one, Use the following examples when notifying the user that you've successfully booked their appointment. So these are examples just for that message once the booking is successful. Let me paste in my first example. Let's have a look. I have successfully booked your appointment. Here are the details. We're using markdown formatting, so date and time and email for booking will be bolded because of these asterisks. And here we have the time and date, the format. We're saying the date and time, 24-hour clock. On Wednesday, we mention the day, and then the month and year. Email for booking, jane@doe.com. And then if you need to cancel your appointment, please call a specific number. So this is how we'd like them generally to look like. And we want to provide an example instead of defining every single rule of everything, like it should be in the 24-hour clock and this, because it's less effort, less tokens, faster, more efficient, and can provide some context that maybe a list of rules can't. A few things we can do to improve it. The first thing is the AI agent might not know where the example starts and stops, especially if we've got stuff after this. So we can wrap it in an example tag. Now, this example tag, it's kind of like pseudo XML. In here, I know that we're then mixing Markdown and XML for organizing my things. The reason I'm using XML here is because it has a start and an end. You could say the same case for these examples. These themselves could also be XML. At the end of the day, most frontier models that I'm using today, these models work totally fine with this mix and match, and this is what works best for me. If you wanted to use Markdown in here, for example, something like example 1, that probably will also work. So there is a preference. I will say that Anthropic models were trained more on XML data. That could change over time, but they are used to XML a bit more. OpenAI models were trained a bit more in Markdown. But again, they're sophisticated models, and this is not very complicated XML or syntax. So again, there is a bit of a preference to it. So I have my example. This would be technically a one-shot example. And with only one example, it's not really sure what's placeholder and what needs to be swapped out and not, right? So let's strengthen it by adding another one. If I paste it in, we'll notice some differences, and I thoughtfully chose and created this example to be a contrast to the other example. So the way I like to think about examples is there's a canvas of good that I'm trying to explain to the AI agent. If they paint here, it's bad. If they paint here, it's good. When I pick my examples, I try to pick examples that are kind of defining that box so it understands the difference between the examples and what's consistent between the examples, because those are both different concepts and both useful to helping the AI agent understand what good looks like. So you'll notice with the 24-hour clock, I have one example that's after 12 and one example before 12. That's rather clear that's a 24-hour clock as soon as I've seen something above 12. The next thing is, here I'm using a very placeholdery email. Now, because, again, LLMs are trained on millions and millions and billions of characters out on the world, think in the States, Jane Doe, John Doe is a very common way for placeholder names. And so there's probably going to be a lot of characters around like Mark and placeholder and stuff. If I only use Jane Doe exclusively, it might give too much weight to Jane and Doe, which is why here I'm using a fake email for our CEO. So don't email that email. It doesn't exist. And so that's providing, again, different points to paint that picture of the canvas of good that we want to instruct it to follow. Another thing we're doing is this text is exactly the same and this text is exactly the same. So I don't have to write this text should be exactly the same. I could separately add that as a rule that you should always include the phone number here and this is what the phone number is if that's important or if it's failing at that. But I'm rather confident about providing 2-3 examples, it will adhere to that. 2 examples is probably enough here. Again, you could add more, especially if there's more variability in those examples and you need your AI agent to understand the minutia between those a bit more. One thing we could do to make this even stronger is we have on my example wrapped in tags. Let's now take all of my examples and wrap it in an examples tag and also close that. Okay, this is good. I don't feel like I need to provide specific examples for like the voice and tone and how it should interact with the user like a chat thread. But if I wanted to, I would have a similar preface for here are some examples of the tone, of the interactions with users. I use those as inspiration or abide by them. And then similarly, I might have a little chat thread in here wrapped in example and multiple chat threads wrapped in examples, all underneath the examples section. All right, let's continue. So far, throughout the system layer, we've been adding a bunch of context. We've been telling it who it is, rules, how to complete tasks, but additional context. I like to think of this as the sort of environmental context. So your employee, if they came in on a Wednesday, they'd know it's a Wednesday. They'd know what day it is. The LLM model doesn't know what day it is today. That's an example of additional context. So let's set that up. I'll open up my AI agent. And then in the system message, we're going to be piping in some dynamic data now. So that's going to be the time. To do that, we're going to need to use expressions. So let's turn this into an expression. And let's open this up so we have more room to work with. And let's add the additional context section. Okay. So in here, we can add this just through bullet points because there's just going to be a few of them. If there was a lot of context and that context itself had syntax, like if your additional context was for some reason in HTML or something, you may want to delineate it with something like this XML-like format. But in this case, we'll just have some simple ones. So the additional context, we want to let it know what date and time it is because that's relevant for this use case. The date and time right now is... So since we want this to be live, that's where we're going to use expressions. So open bracket, and this opens up the autocomplete here, and we can actually select this $now method. And if I look in the result here, that's rendering to a date time object. Now, what we could do is we could format that. There's various methods and stuff that help me do that, for example, that. But since the LLM is a computer system and it outputs by default this date time object, that's totally fine for it to understand. So what the LLM is going to see is the date and time right now is date time 2025, Perfect. Now, let's also add some quick context about the business. So the beauty salon is called Max's Gorgeous Looks. Best place to get a blowout in Berlin. And, well, actually, best blowouts Berlin. And the beauty salon's phone number is... So this is a good example where we've mentioned the phone number multiple times in the examples, but we've also said these are examples, and we're expecting it to fill some stuff in and out. So let's make it extra clear to the LLM that this is our phone number because we're mentioning that in two different places. Now, again, we could add a bunch of additional stuff like this, but you get the idea. You can add your bullet points. All right, that's additional context. All right, last section for the system layer, and we're going to talk about some strategies on reducing hallucinations. So hallucinations is coming up with stuff that doesn't exist and telling the user porcupines and or lies. When I came up with the curriculum for the system layer, I did have to cut some stuff. So if you're familiar with prompt engineering, you're going to say, Max, what about chain of thought and all these other things? Yes, I did have to cut some stuff. But the reason hallucinations is making the cut is most people think it's pretty bad when your AI is starting to make stuff up. And obviously that's not good for your use case. I will preface that I am not an expert on reducing hallucinations, and there's probably prompt engineers working on fintech stuff that have a lot of deep thinking on this. If reducing hallucinations is something you're running into, or generally you want to school up on it, the first thing I would recommend you to do is go to Google and search Anthropic reducing hallucinations and read Anthropic's article on reducing hallucinations. I'm going to go on some of the things through this and give a bit of voiceover, but that's my advice. Okay, the first thing that you're going to want to let the AI agent do is allow it to say, I don't know. Give it an escape hatch. Otherwise, if you're saying you're helpful, you're an assistant, it's going to try to keep helping, even though it doesn't have the tools or the context in order to do that. We've kind of already addressed that, so let's take a look. If we look in the rules, we say, don't make things up, and ask the user for clarifying questions if you need additional information to complete your task. So that's kind of an escape hatch. It's not exactly like Anthropic's example, but that's sort of, I think, their guidance applied to this. We could strengthen it with their guidance. So don't make things up. Ask clarifying questions. If you're asked a question to which you don't know the answer, say so. Now, the next guidance isn't as relevant for us at this stage, but when you're extracting lots of information, for example, with tools, it's going to be helpful to instruct the AI agent to output quotes from those tools, relevant quotes, because if the AI agent doesn't output text, like when you're looking through its logs, if it's not outputting it, it didn't think it. So you have it output the things that are going to be relevant. It's going to use the next step because then it thought about it, etc. If you're interested in reducing hallucinations in a sort of MVP low effort way, again, do read this article, but the TLDR, if you don't want to do that, is have some kind of rule or sentence like this. Don't make things up. Give it a way to exit and ask the user for a clarifying question, and tell it to, that if it's asked a specific question it doesn't know the answer to not try to be helpful in that case. So drop a comment if you think there's things I'm missing here, there's things you've heard about, or there's challenges that you're having and you would like to know how to address those with prompting. There was a ton of information packed into this system layer. If you're still watching, you're doing great. We got two more smaller sections because most of the magic happens in the system layer. But there's some key things to keep in mind in the input layer and the action layer. So let's continue. Okay, the input layer is where the actual user request is made. Now, the important point here is the user might not always be a human. So in a chat use case, the user is typically going to be human, but there is some modifications or injections you could be making to their actual request that gets sent in, their actual message. But then you also have programmatic use cases. So this is where the user of your AI agent is another system, very often an API endpoint or something like that. So let's take a look at these two cases and how it would basically set up the input or the user message to get that request done. Let's send a message so that we have some populated data. Okay, can I make an appointment for tomorrow? Now, the reply isn't going to matter as much because we haven't set up tools and stuff. But what happens is if I look in my chat trigger here, we can see it's outputted a payload of data, and it has this variable called chat input. And here's that message that we sent. So basically what's happening is this payload of data is being routed. We see one item of data into the AI agent. And then here we can see in the user message, it's being fed in. And this is what the LLM, the AI agent receives. That's the task, the thing that's supposed to do. The reason this is grayed out is because the source for prompt, the source for user message, is set to connect a chat trigger node. This is the default if you're using the end-to-end chat trigger. Now, if you're using a different type of app, for example, Telegram or WhatsApp, two different things you could do. You could either define below and drag and drop whatever that message is from the user in the incoming node in here, for example, or you could make sure if you're set to the default mode that the text containing that user message is set to chat input by default. For programmatic use cases, this is where you're going to be using the define below format because basically you're going to have probably multiple variables of data that you're intersplicing with a static prompt. And it's going to look kind of like a mail merged email if you've ever done or seen sort of marketing emails where you do personalizations, basically personalizing a static prompt with dynamic data from the task that actually needs to be done. Let's take a really quick look at that with a basic webhook-based example. So let's say in this example, I have an AI agent that is doing something with user accounts. So maybe I have accounts in my system and I want it to check in on the health of the account. Maybe that requires like using multiple tools, getting multiple analyses, and then sort of digesting that and giving a verdict on something, right? So that's something that's rather fuzzy. That's something AI agents are good at. So let's say we sent in this account username. I'm using pin data right now, but let's say this was being sent in every time I'm running the webhook. We would then pipe that into the AI agent, open it up, and with a source for prompt set to define below, we would make the static portion of the request. So for example, perform an analysis on the following username, and then we drag the username and pop it in. Now, this is a really simple task, right? It might be a bit more verbose, or if you've defined discretely what analysis means in your system message and whatnot. Again, this could be rather simple. That's the basic premise of it. Obviously, what happens in here depends on the task specifically, and you can merge multiple bits of data that could be coming from that trigger or it could be coming from multiple intermediary steps before, fetching from a CRM and your sales CRM and support, getting all this data about the user, and then piping that in as context. If you have context from the user, especially in a programmatic case, that doesn't make sense for the actual task itself, you can use the same concept of an expression and piping that into the instructions as well. So if you're making a personal assistant, here we have additional context about the beauty salon that's static. But if you had a personal assistant, here you might have things like the person's name is Max to Catch, they're 30, etc., etc. Right? Yep, that's the input layer. Again, nothing too fancy, but just for completeness. All right, let's move on to the action layer. The action layer is where we define the tools that the AI agent can use such that it can understand how to use them properly. So tools are super useful because they let it interact with the digital and potentially even physical world. So we want to make sure that it knows how to leverage those correctly, especially because tools are more and more going to start having destructive actions. They might be a tool for deleting an email. So you want to make sure it's doing that exactly how you expect it to and not, for example, deleting your whole inbox. Let's take a look. So I've already added a basic check calendar availability tool. Since this tutorial doesn't focus on building tools themselves, I'm just going to focus on the prompting inside the tool itself. So let's open it up. And the first most important thing with prompting for tools is giving them a consistent name. So here in the name of the node, I can see I've called it check calendar availability. I'm not using spaces. You don't have to use this sort of underscore format. You could use camel case or kebab case. The most important advice I could give you here is just don't use spaces, because this is far more specific, and its incidence in the training data, right, is far less likely, because it's almost like a very, very proper noun, because it's very specific. So just use whatever format you're familiar with there. And if you're not, again, it could be dashes, underscores, you could be capitalizing each first letter. That doesn't matter. Just remember, whatever name you pick here, use that exact name when you're referencing the tool. So what I mean by that is, again, in the system message or anywhere else where you're defining prompts, make sure that you're referencing that tool precisely like you wrote it in the tool name. Okay, back in the tool, the next thing that happens when you're defining a tool is there's usually various parameters that you want it to control. That's the case in the check calendar availability tool. In fact, in this tool, we have to define the after and before time. So it's a date time and a date time that defines a window with which we want to fetch events within that window. So we're using the from AI method that I went over in the last video. And here the name is events after. So often my guidance is use the exact same name here, but if that doesn't feel descriptive enough, add to that. So I did, it's events after and events before. And then I did choose to have a description here. And I basically said revert returns events after this time, use this format. And so by doing the use this format, I did not have to include a type, etc., because some of the formats that you have, this is in a string format potentially. So you can't define that by a type, so you show it as an example in the description. Now, a little learning when you're working in N8N is you're going to come up with this case often. Let's say this is how this parameter looks by default. I might not know in what format I need to specify it. If you ever have a situation like that in N8N, in the fixed mode, pick a value, then go to expression, and it'll convert that value to the plain text format it expects it in. And then you can just copy that and use that in here in your format. All right, let's reset this and continue. So the last step basically in defining your tool is the description of the tool. The description can be simple, like use this tool to da-da-da-da, and it can also include some of the instructions and those sorts of things that we're seeing in the system message, but scoped for the tool itself. You're going to see a lot of people putting that kind of stuff right in the system message, right in the system layer, and just shipping it. That's fine. And that's also fine if you're creating a little AI agent just for yourself. But when you think of teams or you think of iteration and doing things well, there's a concept of separation of concerns. Now, again, if you have an engineering background, you're well aware of this, but the TLDR is if the prompting relates to defining the tool, keep that in the tool, because then you can copy and paste that tool. You could swap that tool. Maybe tomorrow we're not going to use Google Calendar, right? Maybe management says, hey, we're switching to Outlook. Oh, no. I think that's their email app, actually. I'm very not familiar with Microsoft's ecosystem. And so you want to separate the concerns. So this is an app tool. It does have a tool description by default. In this case, since our tool has to go get the actual events that exist for that period and then determine the space in between, we're going to need to have a bit more description. So you're probably not going to need to do this step if it's just like a create lead action, because N8N is going to preset a description for it. And for something like create lead, if you added an action, it's to create a lead, that's enough information for that. So we're going to change this to set manually. Now here, there is a placeholder. This placeholder is not what's sent along with sent automatically. It would, in fact, pass along the resource and the operation that's happening as well. But in this case, let's set a description that allows it to actually get availability and describe what that is, because it's a multi-step process. The first thing we want to do is tell the AI agent when it should use this tool. Use this check calendar availability tool, I'm using the same name as in here, to fetch existing appointments for a specified period and determine when there are available time slots that can accommodate a new appointment. Again, most high level, and I almost always have this format, use this tool to right? Just like if you were talking to a human about this. And since this tool, every time you use it, it's going to return some data, and there's a few specific steps it has to think through to get the thing that it actually needs. This is a great case where you can have instructions just for when it uses this tool. So once again, we'll add a section. Okay, for the first point, it needs to specify the date and range to fetch events for a specified set, this, and this, and this, and this, right? We might not need this step, but I'm showing that I know I need that to happen every time, so I would like to define that for my AI agent. I don't want variability on this because I don't think my use case needs it. Okay, next step, retrieve existing appointments. The tool will return all booked appointments within the specified date, time, and range. 3, calculate available slots. Once you have the existing appointments, calculate the gaps between them to find potential availability. Ensure each gap is at least as long as the required appointment length. Do not allow any overlap with existing appointments. It's nice and clear. Now, here's a life hack. My original bullet points here, or steps, were a little bit crappy. I used ChatGPT to make them better. The prompt that I used was very simple. It's basically, you are an AI prompt writing expert. Improve these prompt snippets for a tool. Snippet, not the entire prompt. If you're giving it a part of a prompt and it thinks it's a whole wider prompt, it's going to give you a whole lot. And then I extracted the things that were clear to me if I had to do the task and took those. So that's my PSA to you. You can use GPTs. There's various prompt helping tools that lots of people online are talking about. So I'm not going to spend too much time on talking about that. But learn these basics, learn these skills so you can audit the work of your AIs. Otherwise, you'll have no idea if they're giving you BS or actually useful prompting. Okay, so I've got these steps. Now, one thing we can do here is, after you have some instructions like this, reaffirm. By following these steps, you can accurately find valid appointment windows based on the already booked events. This is not a scientific thing, but I've been hearing from some folks that basically after you have a step of instructions, some syntax or some words to this effect can improve results, basically. All right. That's well defined. Let's check calendar availability. I'm not going to build the other tool because it's going to be this exact same principle, and this is not a tutorial about tool building, but let's show this working. So, can I book an appointment for Friday? Okay, that is correct. And if we look here, we called the model first, and then it used the availability tool. It correctly set events before and after, returned back the events that we have. It did some thinking, and then it outputted the time slots. Action layer, check. If you're watching this, you just got through the 3 layers of AI prompting or skipped through a bunch of it. So congrats to the first half, and the second half, go back and watch it. No, seriously, this was probably the most in-depth video I've done to date, and it's a lot harder to have nice continuity and clarity across a 40+ minute tutorial. So thank you very much for supporting me as I figure this out. And please do let me know what you think about structuring it into these 3 layers. That's a concept I came up with. I basically did a bunch of research, took my own experience, took some of the experience of some folks that know a lot about this, and try to put it into something that's digestible, right? You see these videos telling you the ultimate tutorial, everything you need to know about prompt engineering in like 45 minutes. It's not possible to fit everything that people know about prompt engineering in 45 minutes. These are like professions. And if you're good at it, professions that pay you a shitload of cash. So clearly, you can't teach someone a 350K job in 30 minutes. But I hope the concepts I've taught you here empower you to build more with AI, to roll your sleeves up, and to build something that you can own and that you can improve over time, and so that you feel that magical wow feeling when you see AI automate some drudgery or do something that you've been doing manually and gives you time for the human things in your life. This tutorial series is part of my work at the studio at N8N, where we build AI and automation use cases and also share those with our global N8N community. So, I'll catch you on the next one, and happy flowgramming.